So the interaction models, what's the idea of an interaction model? So if I have a model like this, yi is equal to alpha naught plus alpha 1 xi, or let's say x1i plus alpha 2 x2i, and I stop here. So suppose I have this model, and this model is telling me that, okay, alpha 1 would show me the effect or the change in y due to the change in x1 holding constant x2. So x2 is held constant, okay? Now, what about this one is the same. So it would give me the change in yi due to the change in x2i holding constant x1. So suppose that this is your salary, or the salary or the wage of a person. This is the, let's say, education, years of education or years of schooling, and this is the years of experience. So each one would have a separate effect on y, but I might be interested in their simultaneous effects. So then there's simultaneous effect. So what if I'm interested in certain years of education complemented with certain years of experience, okay? So I need two things happening at the same time. In order to do that, we will need to update this model by adding an interaction term. So plus alpha 3 x1i times x2i. So this interaction term is showing me the effect of x1 on y in the presence of x2, or the effect of x2 on y in the presence of x1. So interaction term, and this one is called interaction coefficient. Okay, so interaction term and interaction coefficient, and is used to give us the simultaneous effect of x1 with x2. All right, so we have different types of interaction models. We have like 3 types, and let me write them here, and then I'm going to go over them in details. So we have basically 3 types of interaction models. All right. So I have, first of all, I have interaction between 2 dummy variables, right? I have interaction between 1 dummy variable and 1 continuous variable. Okay, and I can have here 3 different cases. The first case is, what if I have same slope, different intercept? What if I have the opposite, different slope, same intercept? And as you might expect, so it's different in both, different slope, different intercept, right? And then the last one, interaction between 2 continuous variables. Okay, So let's start with the first one, which is I have two dummies. So let's see this example. So let's start with interaction between two binary variables, okay, or two dummy variables. So suppose I have this model. So I have yi is equal to beta naught plus beta 1, d1i plus beta 2, d2i plus ui. And I want you to imagine that so far I don't have any interaction terms here, right? So let's see, and you know that this one would represent the effect of d1 on y holding constant d2, and d2 would and beta 2 would represent the effect of d2 on y holding constant d1. Now, if I want to add an interaction term, then I would have to update this model by adding a multiplication of the two. So plus beta 3 d1i multiplied times d2i plus ui, right? So again, this is the interaction term or the interacted regressor. You can call it interacted regressor or interaction term, it doesn't matter. So suppose that d1, it's a dummy, so it's going to take like 1 or 0. So suppose that d1, it takes 1 if the person is female, and it takes 0 for male, and suppose we have just two gender types. And d2 is the binary or the second binary that takes 1 if the person is a college graduate, and it takes 0 otherwise. All right, so now we need to analyze the following. What is the effect? And I forgot to mention that this is earnings, okay, or log earnings. So this is how much they earn. So this is earnings. So I want to analyze the effect on earning due to having a college degree or not. Okay, so if I want to see whether having a college degree affects my earnings, then I have to see the impact on Y for the presence of D2 versus the non-presence of D2, right? So if I have this model with D2 and versus the model without D2, then the subtraction of both models would give me the effect. It's exactly like the idea of taking the first derivative with respect to D2. But these are binary variables, so we cannot take a first derivative, right? Because it takes only 0 and 1, doesn't have anything in between. It's not continuous variable. So if I want to see what is the effect of college degree on earnings, which is Y or Y. So in order to do that, so the first thing is, okay, what is the effect of no college degree? So when D2i is equal to 0, I plug 0 everywhere I see D2i. So the model would be yi hat would just be equal to beta naught plus beta 1 D1i. So this is the model if the person has no college degree. Okay, now what is the person, what if the person has a college degree? So D2i would be equal to 1. And I plug it in the model and I'm gonna get, okay, I'm gonna get yi hat is equal to beta naught plus beta 1 d1i plus beta 2 times 1 plus beta 3 d1i times 1, right? So this means that it's basically equal to let me combine like terms. So constant, let me just add the hats everywhere because this is an estimated model. I keep forgetting adding the hats, okay? So now, I didn't add the hat here because I have an error term. So this is like the main model, the population regression model before the estimation. Now let's combine them. So I have a constant here and I have a constant here. So my new constant would be beta naught plus beta 2, right? My new intercept would be beta hat 1 plus beta hat 3 D1I. Okay, so this is the regression for college degree. Now, if I want to ask you what is the effect of a college degree, then I'm going to have, okay, this is equation number 1, this is equation number 2. So the effect of college degree would be 2 minus 1, and this would be like, okay, 2 minus 1, the beta naught would cancel, so I'm left with, so the change in yi hat because of, or the change in earnings because of having a college degree would be beta hat 2, this is the new intercept, and then this term minus this, the beta 1 would cancel, so I'm left with, this is beta 3, all right? So this is beta 3, so I'm left with beta hat 3 D1I. So the effect of education or college degree depends on gender. So like looking here, okay, this would give me the effect of having a college degree, and this would give me the effect of a college degree in the presence of type of gender. So I can actually make this more specific and say, okay, what is the equation for males and what is the equation for females? So we said that this dummy will take 1 for females and take 0 for males. So for the females regression, or if the person I'm talking about is a female, then the additional wage is going to be equal to beta hat 2 plus beta hat 3 times 1, which is beta hat 2 plus beta hat 3. And remember, this is in dollars, okay, because this is the change in earnings. And if I'm talking about if the person is a male, so this is the change in yi is equal to beta hat 2 plus beta hat 3 times 0, then this is beta hat 2. Okay, this is the impact or the final amount of additional dollar for additional year of education for a female applicant, and this is for a male applicant. Okay, and it's in dollars based on the, if I'm assuming that y is in dollars. Any question? Okay. Next, suppose I have, so this is number 2, interaction between 2 dummies or 2 dummy variables or 2 binary variables, whatever. All right, and in this model, I'm gonna have like, right, 2 dummies interacted at the same time. And again, let's keep the same story. Y is the earnings, okay? And did I say 2 binary? Wait, I didn't. Oh, we already had 2 binaries. Okay, we are still here. Okay, let me give you actually, before I start the next one, I'm gonna give you an example. So suppose this example, I have earnings hat is equal to 590 minus 20.4. Dummy for females, that takes 1 if the person is a female, 0 male, plus 150. Dummy for experience, that takes 1 if experience is 3 or more, minus 35. Dummy female multiplied times dummy experience. And let's define these dummies. So DF takes 1 for female, 0 male. D experience takes 1 if experience is greater or equal to 3 years, and 0 otherwise, or less than 3, strictly less than 3. Okay, so I wanted to look here and I wanted to imagine that you basically have 4 cases. So the person can be male with 3 or more experience, female 3 or more experience, or a female with less than 3. Can be a male with 3 or more experience, or a male with less than 3 years of experience. So I have actually 4 cases. So anytime you have 2 dummies in a model, I want you to think of 4 possible cases, and you can come up with 4 different cases. So I want you to think about worst case, assuming discrimination between males and females in the labor market, and the best case. Of course, can someone tell me what is the worst case? And these are intermediate points. So what is the worst case? I do have here every case. I have a dummy for female and a dummy for experience. Dummy for female, dummy for experience. So let's see. So if I'm assuming that females earn less, and of course with small number of years of experience, then it's even worse. So what do you think the values for DF and DE? What about Dan? You have an answer?
DF.
Bart?
Wouldn't DE be less than 3 or 0?
You guys, I can't hear you. Can you type in the chat? I think I have a problem with my mic. Guys, can you hear me? Because I can't hear you. Wait.
Yeah, I can hear you.
Less than, yes. So I just want to make sure, guys, that my mic is working.
Yes, we
So
can
let me
hear
know.
you.
Can you hear me?
I
can't
hear
hear you guys. Like nobody's talking. Just want to make sure. Are you guys quiet or okay? You can hear me. Perfect. Can you try your mic, please? Just say anything.
Hello, hello.
Because mine is not working. Like I can't hear you. Yes, so I cannot hear you. Yes, that's a problem. Okay, I'll figure out this after the class. I do get a notification from Zoom that I need to update my audio settings, so I'm gonna do that right after class. So anyways, if you have any question while I'm talking, since I can't hear you guys, just type on the discussion forum. And yes, so then let me continue here. So the worst case, as Dan typed, and as you guys said on the chat, so here the worst case would be like a female, so this one has to be 1. So this one has to be 1. You might, okay, 1, and less than 3 experience. Okay, and then this definitely would be like a male with more than 3 experience. And then I do have like 2 intermediate cases in between, which are not, we are not 100% sure which one is stronger. Is it female or experience, but which is the factor of female versus the experience. But definitely you can do that. You can look at the coefficient here. Experience by itself increases your earning by 150, but being a male just 20, right? So it seems that experience is stronger, right? The fact of having experience is stronger. So the intermediate case would be here. This is a male and experience is less than 3. And this is a female and experience is here. So we plug in the 1s and 0s and you will get these numbers. So you will get earnings here would be, if you plug 1 and 0 into this equation and you solve for the earnings, you would find earning is equal to 569.6 and then 590 and then 6846 and then 740. And when I say best case, because I see the earnings are the highest, and the worst because the earnings are at their lowest point. Okay. Okay, so this is about an interaction between 2 dummies, right? So I have a dummy and I have a dummy and I have their interaction. We're done with this part. Our next case would be, okay, if I have, which is number 2, what if I have interaction between 1 continuous and 1 binary or dummy variable? Okay, so suppose I have this model. So yi is equal to beta naught plus beta 1 xi plus beta 2 di plus ui. And let's assume, okay, this is again earnings. And this is experience in years because it's a continuous. And this D is gonna take 1. Let's make it for males. It doesn't have to be females every time, males. And then 0 for otherwise or for female because we have only 2 gender types. Okay. Now, if I'm asking you, can you check if the effect of experience on earning is the same for both gender? Like, can we check that? So if the effect of experience on earning is the same, by looking at this equation, the answer is yes, because this is experience, right? And this is the effect of experience on earning, and it doesn't seem to be different from both gender because it's not interacted with the gender type. Okay, so let's see. If di is equal to 1, then this is the equation for male, a male worker, for example. Then the yi hat would be equal to beta naught, right? Plus beta 2, because beta 2 is multiplied times 1, I can combine it with the intercept, plus beta 1x. Why I wrote here x1, this is, you can think of it as xi, okay, which is the experience. And if di is equal to 0, then this is the equation for females, and yi hat is equal to just the beta naught plus beta 1 xi. So if I'm asking you, is the impact of experience is the same? Yes, because the beta is the beta. So if I don't have any interaction term, then actually both gender would have the same amount of additional earning for each additional year of experience. The only thing I want you to notice is, I want you to notice this part. See this intercept versus this intercept. The intercept for the male models versus the intercept for a female model. So this one is telling me that this is the amount of earnings in dollar that a male person would get if experience is 0, right? So at 0 experience, then you plug in xi equals 0, then this part is gone, this part is gone. I'm left with just the intercept, and this is the definition of an intercept. So if I at experience 0, males earn beta naught plus beta 1, beta 2, okay? Beta naught plus beta 2 dollars, and females earn on average, remember everything is on average, right? Beta naught dollars. So this is what we call a model with same slope, different intercept. So despite the fact that the effect of education, the effect of experience is the same for both gender, at 0 experience, they earn different amounts. And this is why, because I'm setting up this model such that the coefficient attached to the continuous variable is the same, which is beta 1 for both gender, but I do have a dummy which is added to the intercept, creating a new intercept. Okay? Now, what if I want to have a model that would show me something more realistic? I want to have a model that would show me that additional year of experience implies a different amount of earning depending on the gender type, okay? And this is more realistic because this is what we know. It's like what we know in the US market and many other countries is that it's not only the case that at 0 experience, males and females earn differently or males earn higher than females, but it is also the case that for each additional year of experience, earning is not going to increase by the same increments or the same amounts. So in order to do that, we have to introduce a new type of a model in which I have different intercept and different slope. So this is second case, right? Which is different intercept, different slope. And just to not get lost, so remember, everything is still under this big topic, right? Which is the interaction between one continuous and one binary. We discussed the first case, okay, which is same slope, different intercept. This is, let me write here first case. This is the first case. And this is our second case in which we have different intercept, different slope. And I actually prefer this model because many applications, it's more realistic. So this model, in order to be able to get different intercept and different slope, I need to add a dummy because this one would be added to the intercept of the model, creating a new intercept. but I also have to have an interaction term that it's going to affect the impact of experience, okay? So in order to see that, so basically, again, we're gonna do it the same. When di is equal to 1. So when di is equal to 1, I'm going to get the male regression. And when di is gonna be 0, then I'm gonna get the female's regression. Okay, so the di1, this is the male regression depending on our definition. And this is going to give me, just plug in 1 everywhere, combine the intercepts beta 0 plus beta 2 plus beta 1 plus beta 3 xi. Now, if di is equal to 0, I get the female regression, and the female regression is easier when I plug in 0 because everything is gone. Everything that has a di, this is gone, this is gone. I'm left with just this part, right? So yi is simply equal to beta 0 plus beta 1 xi. I want to compare this one versus this one, okay? So when I look here at the females, at the male regression, at 0 experience, they earn differently, right? So at 0 experience, males earn beta 0 plus beta 2, females earn beta 0. So this is at 0 experience, okay? What about additional year of experience? For each additional year of experience, right? Males earn beta 1 plus beta 3. Females earn beta 1. This is more realistic, right? Assuming that all these coefficients are positive, assuming like all of these, like I need to have the hats everywhere. These are like the estimated model, assuming this is the estimated model. So that means at zero experience, we earn differently, males and females, but also for each additional year of experience, the slope is different. So this model is a case in which I have different intercept and different slope. And I prefer, again, this type of model in many applications because it's actually more realistic, right? When I talk about labor market discrimination, it's not about 0 experience that we earn, that we have males are earning higher, but it's also for each additional accumulation of experience, the slope is higher for males versus females, okay? All right, so let's talk about the third case. We discussed the first case where I have a same slope, different intercept, different slope, different intercept. Now, what about case 3, where I have same intercept, different slope, okay? Same intercept, different slope. So in this case, let's have a model where I have yi is beta 0 plus beta 1 xi plus beta 2 xi times di plus ui. Now, again, if d is equal to 0, this is the female's regression, right? So yi is equal to beta 0 plus beta 1x. If di is equal to 1, this is the male regression, then it's yi is equal to beta 0 plus beta 1 plus beta 2, right, xi. Now, again, at 0 experience, they earn the same. Okay, which is beta not dollars. So they earn the same at 0 experience, which is not realistic because we know, like in the job market, we know there is a discrimination. So even 0 experience does not imply that they earn the same amount of dollars. And for each additional year of experience, we have 2 cases. For males, they earn beta hat 1 plus beta hat 2, and for females, they earn just beta hat $1. Okay, so that means we have same intercept because they earn the same at 0, but we have different slope because for each additional year of the continuous variable, or which is experience, they do earn differently. Okay, any question? Okay, if you have any question, again, type on the chat because I can't hear you guys. Okay. What we can do, okay. I'm gonna give you an example. I'm going to show you a few things in the example, and I'm gonna ask you to do a homework for next week. Okay, so let's see. Suppose I have this log model, okay? So this is log linear. So I have log earning is equal to 6.92 minus 3.13, dummy for age, binary variable, minus 0.019, age, continuous variable, plus 0.085, age multiplied times dummy for age. Okay, now let's define the dummy. So this dummy variable is a binary variable, dAge, that takes 1 if age is less or equal to 39, and it's going to take 0 otherwise, or if age is strictly greater than 39. So this model, I'm using it in order to be able to differentiate between people who are 39 years of age or less and people who are older than 39. And so this is a dummy. For the age, it's a continuous variable. Okay, so it's like, okay, 21 years of age, 22, 25, 30, whatever. So it's just like not a 0 of 1 variable, but it's a continuous variable. Now, this interaction term is here in order to do the differentiation between people who are above 39 and people, or people who are 39 and less, and people who are strictly more than 39. Okay, so if I ask you, what is the earning equation, or what is the regression for if age, or for age less or equal to 39? Okay, and what is the regression if age is above 39? So one regression, I'm going to plug in DI. So this one implies that D age is 1. This one implies that D age equal to 0. And if I plug 1 and I combine, then log earning. I read log earning as learning. Okay. Log earning is equal to 6.92 minus 3.13 multiplied times 1 minus 0.019 age, right, plus 0.085 age times 1. So there is another 1 here multiplied. I want you to combine any number. So if you leave for me a question and if you leave for me the equation this way, you will lose points because you will have to combine all the numbers together, all the slopes together. So that means your final answer would be like this. Log earning is equal to 3.79 plus 0.066 age. Okay, and for if age is equal to, this is easier, right? So here's 0, here's 0, so I'm just left with this part and this part. So in this situation, log earning is equal to 692 minus 0.019 age. Okay, and so basically this regression predicts a negative relationship between age and earning only if age is above 39, and a positive relationship otherwise. Okay, so a positive relationship otherwise, which is if age is equal or below 39. Okay, now I can use this regression to answer many questions. And these are the questions that I want you to answer. So write the null hypothesis for the following test. It's not a question mark, it's just, okay, write the null hypothesis for the following tests. Number 1, and this is your homework for next week. I want you to write the null hypothesis for testing whether age above 39 has the same effect as age of 39 or below. I want you also to repeat, write another null hypothesis that tests whether the two regression lines have the same slope. 3, test whether the two regression lines have same intercept. Okay, so this is your homework for next week, and we're going to discuss your answers. And again, I don't want to give you the answers now. I can easily go over them and give you the answer, but I just want you to think about it. I want you to write your answer in terms of a null hypothesis like this, okay? And see what is the coefficient that you need to test and whether it's equal to 0 or it's a joint test. Probably it's a joint test, okay? So maybe I'm testing more than one coefficient, so you will need to find out or figure it out, and I'll ask you next week. Okay, the last type, it's the easiest type, which is the interaction. I'll discuss this one and I'll give you like 5 minutes break. So number 3, interaction between two continuous variables. So this one is the easiest, and I'm going to tell you why. So I suppose I have beta naught plus beta 1 x1i plus beta 2 x2i plus beta 3 x1i multiplied times x2i, and suppose that, again, this is earning, this is experience, and this is education, okay? And now suppose that I want to find out what's the impact of experience on your earning. I can easily do a first derivative. So what is the impact of experience, or what's the first derivative of this equation with respect to experience? Then it's going to be equal to beta 1 plus beta 3 x 2I. So the effect of experience on earning depends on education. So your education is a factor into this slope, right? So effect of experience on earning would depend on the level of education, right? So this is a type of a continuous, of a two continuous variables. I'm saying it's the easiest because in order to find the effect, I don't have to find like when D1 is 1, when D1 is 0 and take the difference, because it's a continuous, two are continuous. So I just take the first derivative of the equation and it's easily like would easily give us the answer. Okay, so this is the end of the interaction models. I'm not spending time on the two continuous variables because it's the easiest, as I said, to find out their impact. Let me give you like a 5 minutes break. I'll be back at 2:03. Okay, and then after I'm back, I will continue this topic, but showing you this data application. All right, so I'll be back in 5 minutes.